morning, good afternoon, good evening, depending on the time you are watching this video. You know, we have some challenges reaching each other through the Zoom class or whatever online class, network breaking, and all these challenges. We are not able to communicate effectively with each other. So I want to take the option of recording some videos so that perhaps it may be better. So the course is TEL 437 Digital Signal Processing, and then I will show you the course content now. This is the course content. This is the course content. The 437 Digital Signal Processing is a required course. Signal representation in time domain, Fourier transform, sampling theorem, linear time invariant system, discrete convolution, Z transform, discrete Fourier transform, discrete filter design, basic image processing concepts. It's a 2-unit course. Now, let's start with signals. Signals and systems. Signals and systems. Signal carries information. Carries information. Systems process or processes signals. So we're interested in signals, we're interested in systems. Now, you can find the definition of systems. You can, any of your whatever, you can find what's a system. There are systems in social sciences, there are systems in engineering, there are biological systems. A system would be a collection, a connection of subsystems, of components to perform a particular function. Now, we have types of systems. We can talk of linear system. A linear system is a system such that the relationship between the input and output is a straight line through the origin. That is, if this is the input and this is the output, the relationship between the input and output is a straight line through the origin. Output is proportional to input. And it's a straight line through the origin. This is what we call a linear system. A linear system obeys superposition theorem. Obeys superposition theorem. Obeys superposition theorem. Now, my daughter, yeah. When we say a system is linear, what do we expect? When we say a system is linear, what do we expect? We expect that if F1 is the input to that system and it gives an output of G1, or let me say FA is input and GA is the output. If FA as input leads to GA as output. If FB as input leads to GB as output. When we double the input, what do we expect? The output will be doubled. We are going to see 2GA as the output. If we send in 3FA, our output, you can guess, is going to be what? is going to be 3GB. That means when you double the input to a linear system, the output becomes double. When you multiply the input to a linear system by 10, the output becomes multiplied by 10. Now, if you bring in 2FA plus 7FB, you can guess what's going to be the output if it is linear. The output is going to be 2GA plus 7GB. This is the idea of superposition theorem we are saying. So that is a linear system. The opposite is non-linear system. The opposite is what? Non-linear system. A system can be linear or can be non-linear. If it is non-linear, it's exactly the opposite of a linear system. The relationship will not be a straight line through the origin. It can be a straight line, but if it doesn't pass through the origin, it will not happen like that. So, layman explanation is that if I give you 1,000 naira and you laugh twice, by the time I give you 2,000 naira, you should laugh 4 times if you are a linear system. So, that is a linear. So, a non-linear system is the opposite. Then, the other type of system we want to introduce is what we call time invariant system. 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 A time invariant system is a system whose characteristics does not change with time. A system whose characteristic is it ER, characteristic, does not change with time. What do you mean by that? What do you mean by characteristic is that if given FA today as input, we get output GA. What happens tomorrow when we give this same tomorrow? When we give this same input FA, if it's a time invariant system, the output should be the same. The output should be GA. If day before yesterday we give the same FA, the output should be GA. That means it is a time invariant system. The characteristic does not change with time. You are my student. If I slap you today, you will laugh 3 times. You will say thank you, sir. Now, in the next 10 years or 15 years, when you come to campus with your wife or husband, with your children, I still slap you, you should say thank you, sir. That means you're a time invariant system. But if I slap you now, because I'm a student, you laugh, you say thank you, sir. And in the next 15 years, you come, I slap you, say, oh, God, be careful. That means you are not a time invariant system. The opposite is time varying system. Time what? Varying system. That's the opposite. The characteristic change with time. For example, the dollar is not a time invariant system. From 10 years ago, $1 will give you 150 naira. Now today, $1 will give you about 450 or whatever. That means it is a time invariant system. It is a time varying system. Now, the other definition we want to introduce is what we call stable system. Stable system. Stable system. When the input is bounded, the output should also be bounded. The output should not grow to infinity. If the input is not growing to infinity, the output should not grow to infinity. So we say the system is stable. But if the input is bounded and the output is not bounded, then we say that system is unstable. Ladies and gentlemen, if somebody is dancing to a music or to some drum being beaten, please, when that music stops, what is that person supposed to do? He's supposed to stop dancing. If he doesn't stop dancing, they will ask him, are you okay? You understand me? So if we give you an input and the input is limited in size, the output should also be limited. So the opposite of this is what? Unstable system. Unstable system. Another thing we want to introduce is causal system. Causal system. A causal system is such that present output does not depend on a future input. Then we say that system is a causal system. But if the present output depends on a future input, then we say it is what? Anti-causal system. Let me ask a question. The balance in your account today, does it depend on the deposit daddy or mommy is going to deposit in your account tomorrow? No, it doesn't. Your balance in account today depends only on what has been deposited before now, not on what will be deposited tomorrow. So which means your bank account is a causal system. Lastly, we want to talk about memoryless system. Memoryless system. Memoryless system. Memoryless system. Present output does not depend on past input. This one does not remember. This one does not remember. This one does not remember. The present output depends on either the present input. It doesn't depend on the past input. It doesn't remember. It doesn't have memory. The opposite is a system with memory. A system with memory is the opposite. This one has memory. The present output will depend on the past input. It's a system with memory. So a particular system will take each one out of these opposite characteristics. It may be linear but memoryless. It may be linear but with memory. It may be linear, causal, or linear, anti-causal. It will take the five, isn't it? Stable. It will take all the five properties. It will take one of the opposites. So now, then at this level, we like you to be familiar with what we call LTI. LTI means what? Linear time invariant system. So most of the systems we are going to be studying here, they will be what we call linear time invariant system. It is linear. Linear means when you double the input, the output will come down. Time invariant means that the same output will be given to the same input anytime you apply that input, whether yesteryears or whether presently, even in the future. What will make a system not to be like that is age, wear and tear. They make it such that that may not happen. But when we say time invariant system, which means give it one particular input today, to give you a particular output, the output will be repeated anytime you present the same input. Anytime you present the same input. If the exchange rate were to be a linear time invariant system, it should have been 150 naira to dollar every time. Years ago, presently, and in the future. But it is not like that, isn't it? So it is a time varying system. So we'll be studying at this level mostly linear time invariant system. I will only mention two. They can also have, it may be either it's having memory or it's not having memory, either it is causal or anti-causal, either it is stable or unstable. So, because of size of the video, let's stop our video 1 here before we proceed. Thank you very much. Thanks for listening.